Okay, so in this video we're going to start into an introduction on the mole. Before we start the mole, we're going to have a quick look at the periodic table of elements just to explain a couple of things about it. So when you're looking at your periodic table, for Leaving Cert Chemistry, you're going to get slightly more accurate numbers. So for example, I'm going to take this one here, which is carbon. And you can see carbon on this periodic table. 6 is the top number, then we've got C for our carbon, and then we've got 12.011. Now, we generally always round to the nearest whole number. So when we do our calculations on mole, what we're going to be interested in is this number here at the bottom, which is the mass number. And the mass number for carbon for our calculations is 12. It does say 12.011 over here, but again, you don't need to put in those final digits. The same thing for nitrogen. When you're dealing with nitrogen, you would be dealing with 14. And with oxygen, you can see is 15.99. So in that case, you would round up to 16. And pretty much every mass number is going to be the same. There is one or two small differences. So for example, chlorine is one exception to the rule. So you can see there, chlorine is 35.45. So for chlorine, what we're going to do is chlorine is 17 on the top, and we will have it at 35.5. So again, it's almost at 35.5, so that's what we round to. The other one that we're going to round in the middle is going to be copper, which is down here. So you can see there copper is 63.546. So again, if you have to use copper, it's going to be 29 copper, and then we're going to have 63.5. Pretty much everything else rounds up or rounds down, depending on how close it is to the number. Okay, so now that we have that in mind, then we're going to explore the idea of what the mole is. You'll need your periodic tables to work out the moles now in a second. Let's explain what a mole is. So in chemistry, when we're dealing with the mole, 1 mole of a substance is just a unit. It's like saying 1 kilometer, if you have 1 kilometer, or if you have, say, something like 1 kilogram. A mole is just a unit, and what we use the mole to do is to work out the amount of atoms or particles in a substance. Now those particles, they can be molecules, but you can also have ions and sometimes electrons as well. So any of these, atoms, particles, ions. A mole is the unit for working out how many we've got. Now, 1 mole is always the same amount. So 1 mole of a substance is always 6 by 10 to the 23, and it's atoms or particles, depending on what you're dealing with, and I'll explain that now as well. Now, to give you an idea of how big that number is, 6 by 10 to the 23, if you took something the size of, say, a marble or a Smartie or something like that, and you had 6 by 10 to the 23 of them, that's a 6 followed by 23 zeros, you would be able to cover the earth to a depth of about 5 kilometers with Smarties or marbles or something of similar size. So this is a massive number. For example, if you have 1 mole of carbon, and this is just your carbon atoms, so 1 mole of carbon is 6 by 10 to the 23 atoms of carbon, if you have 1 mole. If you have 1 mole of sodium, you will have 6 by 10 to the 23 atoms of sodium. If you have 1 mole of water, okay, now again, remember that water is H2O. It's a molecule, it's not an atom. So this is the carbon atom, this one here is the sodium atom, and this one here is the water molecule. You would also have 6 by 10 to the 23, but instead of atoms, you would have molecules. So that's what I'm saying. It depends on whether you're dealing with atoms or molecules. 6 by 20 to 23 molecules of water. And then finally, if you had, say, 1 mole of hydrochloric acid, which is HCl, HCl is also a molecule, so it would be 6 by 10 to the 23 molecules of HCl. So it depends on what you're doing, you have to change whether it's atoms or molecules, and these particles, this word particles up here is just a general way of describing atoms or molecules or ions. Now, some of you are probably looking at this going, well, we've got 1 mole of carbon at 6 by 10 to the 23 atoms. We have 1 mole of sodium at 6 by 10 to the 23. So some people are going, well, what's the difference if they both have the same amount of atoms? Well, if we have a look at carbon, carbon is number 6 on the periodic table, and it's got a mass number of 12. If we look at sodium, sodium is 11 on the periodic table, and it's got a mass of 23. Now the mass number, obviously, carbon, has got a mass of 12. Sodium has got a mass of 23. So which is the bigger atom? Well, it's sodium, it's Na. So if you think about it, having 6 by 10 to the 23 atoms of carbon, let's say this is your carbon atom, the sodium atom is going to be bigger. So having 6 by 10 to the 23 carbon atoms is not the same as having 6 by 10 to the 23 of the sodium atoms, because they're much bigger. You know, it's like saying if you had 6 marbles compared to, 6 cars. You have 6 of both of them, but the size and the mass is not the same. So how do we work out the mass? Well, it's actually quite easy. And we're going to use the periodic table for that, which is why we started there. So if we go and we work at 1 mole of carbon, that's what we're going to start with. So we already know that 1 mole of carbon is 6 by 10 to the 23 atoms. We also know that 1 mole of sodium is 6 by 10 to the 23 atoms. But if you want to know what that weighs, all you've got to do is go to the periodic table and find out what the mass number is. Now the mass number again of carbon, I'll remind you, is 12. So if you take this mass number here, 12, and you make that into grams, that's what 1 mole of carbon is. So 1 mole of carbon is 12 grams. If you want to do it with sodium, it's the same thing. Sodium is 11 Na23. So the mass number of sodium is 23. That means 1 mole of sodium is 23 grams. So although they have the same amount of atoms, because the atoms are different sizes, sodium, 1 mole of sodium, is much more in terms of mass than 1 mole of carbon. It's 23 grams compared to 12 grams. How does this work then for our other example, which was water? So what again if we had 1 mole of water? So 1 mole of water is 6 by 10 to the 23, this time, molecules. Well, water isn't on the periodic table, so we don't have a mass number for water specifically. So what we do is we go to H2O and we write down what our molecule is. And on our periodic table, we find out what the mass number is of each of our atoms in this. So for example, hydrogen is 1, but because we've got 2 of them, we're going to multiply by 2. Then we add it to oxygen. When you go to the mass number of oxygen on the periodic table, it's 16. So here we've got 2 times 1 plus 16. And when we add those together, we get 18. This here is what's called the mass of water. And the symbol for that is M with a subscript R, MR. Now you're going to see me use this MR an awful lot, so it's important that you know what this is. MR just means the mass of the molecule, or the molecular mass. Up here, with this 23, that was the atomic mass because it was an atom. There's still mass, it doesn't really matter otherwise. So what do we do with this? We have now found the mass of water is 18, therefore 1 mole of water is 18 grams of water. And you do that for all of them. You can do the exact same thing for 1 mole of HCl. 1 mole of HCl is 6 by 10 to the 23 molecules. HCl then, if you want to work out MR for that, so you go to hydrogen. Hydrogen is 1 on the periodic table, plus the chlorine we saw earlier on is 35.5. So that gives you a total MR, or molecular mass, the mass of 1 molecule of it, is 36.5. So that means 1 mole of HCl is 6 by 10 to the 23 molecules, and it is 36.5 grams of HCl. Now, the reason why we do this is that means in the lab, if I ask you to weigh out 1 mole of carbon, we don't have a mole balance. You can't work that out. So if you want 1 mole of carbon, you would go weigh out 12 grams of carbon. If you wanted 1 mole of sodium, you would weigh out 23 grams of sodium. If you wanted a mole of water, you would weigh out 18 grams of water. You'd pour out onto the balance until you got 18 grams. And if you wanted 1 mole of hydrochloric acid, you would weigh out 36.5 grams. Okay, so let's try and expand this maybe a little bit more. So let's say we had something like this. Let's say we have 1 mole of oxygen gas. Now, oxygen gas is O2. And we're going to forget about that number 6 by 10 to the 23 for the moment. So 1 mole of oxygen gas, if you want to know what that is in grams, again, you go to the periodic table. Oxygen on the periodic table is number 8. It's got a mass number of 16. Oxygen gas is always 2 oxygens. So it's going to be 2 times 16 from this. So that equals 32 grams. So 32 grams is 1 mole of oxygen. If you want 2 moles of oxygen, O2, again, it's going to be 64 grams. And you do that for all molecules. If you want 5 moles of O2, then it's going to be 32 grams multiplied by 5. Because that there is 1 mole and you're multiplying it by 5, which is going to give you 160 grams. But what happens if you want something a little bit less than 1 mole? Let's say you want 0.5 moles. Well, if you have 1 mole and you wanted to get to 2 moles, you just multiply by 2. And you would do the same thing over here. You take 32 and you multiply by 2. If you wanted 5 moles of oxygen, you multiply by 5. If you want 0.5 moles, you do exactly the same thing. You multiply by 0.5. So if you want 0.5 moles of oxygen, O2, it's going to be 32 grams multiplied by 0.5. And that equals 16 grams. So this basically is a half a mole. And you know, if 1 mole is 32 grams, then half a mole is going to be 16 grams. So anytime you want the number of moles, you just multiply by that number. If you want 0.1 moles of O2, it's going to be 32 grams multiplied by 0.1. And that equals 3.2 grams. And that's how that works. Now, there is a quick way of working this out, and I'm going to show you that in the chart soon. This works now for every other molecule. So if you have 1 mole of another substance, the calculations are done exactly the same. Okay, we'll come back to this in part 2.